Right, so let's talk about keys. So as I mentioned earlier, keys are going to allow us to uniquely identify data sets, right, and data points within a data set. Okay, and one of the things that we have to consider is that we are going to be taking a look at a table and consider it that is going to behave just like a set, right, like an unordered set, right. So all the data in that set has no particular order, even though obviously when you store it in a file system, obviously records will have a particular um, uh, concrete location in the file system. Yes, there will be a first one, there will be a second one, but logically, you should not rely on any particular order that the data is stored. Right? You should literally consider it as a set. So even though the order of the rows are going to be in chronological order as you have inserted them into the database, you should not rely on that. Right? The database is free to shuffle them around or reorder them somehow, right? You should not rely on the order in the row in which they're displayed, right? Anyway, when things are displayed for human consumption, it's only a subset, right? It's a very small sliver of the actual data set, right? The data set might be, terabytes, and you will only be looking at just a few kilobytes at a time, right? So anything you see is only a small sliver of what the actual data might be. We do need some of these records to be unique. By default, databases do not enforce uniqueness. Okay, so a record that two records that might have identical data sets between them, whenever you're going to retrieve or ask anything about those two records that have identical values, there's no way for the database to distinguish them, because there's nothing unique about them. Okay, if you ask how many employees have a particular salary and whatnot, and they have identical data sets, this it'll count them like two instances, even though it might really be one of them. Okay, and if you want to delete a record that has these particular values, there will be no way for the database to distinguish between the two. It will delete both records, right? There's no way for distinguishing. So in many cases, we will need to uniquely identify these things, and we have to decide how is it that we're going to uniquely identify the records. What is it that make us unique? Unfortunately, there's very little that make us really unique. If I say my last name here, probably I am the only one with Annunziato. And then so within this context, perhaps the last name is enough. But if you start, sampling folks, will probably find that there are two or three folks that have the same last name, and say, well, okay, well, what if you combine it with a first name? Well, probably inside of this room, first name and last name will make us unique, right? And so within this context, perhaps, yes, those two fields are enough. But if you sample the whole building, maybe perhaps you will find two people that have the first and last name the same as someone else. So you say, well, how about the middle name, and so on and so forth. So you start, increasing the number of fields that would make you unique, right? Eventually, perhaps you come to the conclusion that nothing really makes us unique as you broaden the scope. Okay, and that's why we have social security numbers, we have phone numbers, we have credit cards number. And these are all randomly generated unique fields within the context of the phone number space, right, or the social security number space. Yes, and so to guarantee this uniqueness. Uh, so notice that it might be that as we start adding fields that we presumably make us unique, it might be that within the context, right, that we decide, maybe it's this building or maybe this university, maybe first, middle, and last name, and I don't know, date of birth makes us unique. But any additional field that I add doesn't make me any more unique, right? So the minimum set of fields that make me unique within a context is referred to as the key, right? If I keep adding more and more fields, we say that the key is a subset, right? Perhaps a larger set of keys. We call that the super key, meaning something that might have additional fields in there that are superfluous. You don't really need them to make me any more unique. Make sense? Right. So maybe my first name, last name, middle initial, and my date of birth is enough to make us unique in the university. If I add my phone number, that's not going to make me any more unique, right? If I add my social security number to that, that doesn't make me any more unique. Yes. So we say that this minimal set of keys is just a key, and you might have other superfluous fields that don't make me any more unique, so they're superfluous. So the keys really that you should select keys based on their intent, right? Their meaning, right? Not whether they are unique within a context, right? So, for instance, if I have a list of the folks in this room, and I find out that luckily the last name makes us unique, then I might inadvertently or naively choose the last name as my unique key. Yes. So I have looked at the evidence of the data set to decide that this is a good choice, right? So what I'm arguing here is that you should not do that. You should not take the content as a clue at what the uniqueness of that field is, right? It might be in this room for now, but maybe somebody else might join later on in the class that makes the last name a bad choice. So it should not be the content, right, that you look at to see if it's unique. You should look at the meaning of the field, its last name, and then follow logic through that and say, okay, well, is the last name really unique enough, right? And then following that logic, you might come to the conclusion, well, maybe last name is not unique enough, right? I'll need to perhaps mix it in with something else, right? So you should look at the intent of the fields that you're considering, not the content. Okay, whether something is a duplicate or not, it should not make you follow that appropriate key. Also, as I mentioned earlier, as you select the keys, certainly if it's a single key, yes. I'm sorry. Right. So you should. My point is that you shouldn't look at the value, right? Because it's always within the context that might be time sensitive, right? That may just now, but it might change over time. That it's not unique, right? Now, obviously, last names we have a very good understanding of what they are. Socially, we know what they mean. But there might be some other domain, right? Maybe physics or quantum mechanics, where you're giving a field and you have no idea whether that field is unique until you understand what it means. It might be that you look at the values and it says, "Oh, looks unique. I'll take that." Well, that's what I'm saying. You should not do that. Somebody should explain to you that field means this, right? And then once you understand it, decide from there whether it's a good choice. Selecting keys, as I mentioned earlier, keys establish constraints. The simplest of constraints is that they are unique, right? That they cannot repeat. That's the simplest constraint, right? That if you try to insert a record that has the same value across the data set, the database will stop you. It says, no, I'm enforcing that rule. They're unique. So these rules together, we call them constraints. But other constraints we can set up might be logical constraints, right? That might be falling from the rules, the business rules, as we read the requirements, right, from our documentation or from having met our clients and through the requirements gathering process, right? They might establish certain business rules, like a student cannot enroll in the same section twice. That's a business rule. And so we need to look to see if we can use the constraints that the database can naturally provides us, see if we could enforce those rules at the database level. Typically, those rules are enforced at many different levels. They're probably enforced at the front end, at the user interface. They'll probably will be enforced again in the database at the server level, right? When you submit data to the server level, and then again will be enforced at the database level. Okay, business rules should be enforced at as many layers at the application as possible. Right, certain things cannot be enforced in the front end, right? Because the front end doesn't have all the data, right? The data, by definition, the front end will only have a very subset, little piece of the data set, right? And usually we'll have to come back to the server anyway, asking for more data and to answer these kinds of questions, right? But to the extent that we can, we should enforce these rules at every layer of the application. In particular, the database, right? Certain things, as we'll see a little later, cannot be enforced at the database level. Or it might be that if we enforce this rule, then we'll break this other rule, right? That there's some rules that will conflict with one another, right? That we cannot enforce both rules at the same time, okay? So it might be that we have to spread the validation and enforcement across multiple layers of the application, or using stored procedures and functions and whatnot, right? We'll see that not everything can be enforced. So this one in particular is enforcing student and section ID, the composite key, right? Together, these two fields have to be unique, and it's enforcing the business rule: no student can be enrolled twice in a section. There's a whole bunch of other things we could enforce. Perhaps if we in some of the tables we might say that the combination of professor and year offered together, that's a primary key together. It's a composite primary key. That would be a rule saying that a professor teaches at most one section a year, right? So if we have the same professor the same year twice, we're breaking this rule, right? And the database would stop you. You says, no, you cannot insert this. You cannot insert this record in there. Or how about this one? A course can have at most one section per year. So course ID and the year offered together cannot repeat itself. Okay, or together course ID, professor, and year offered. Professor teaches at most one section of a course per year. Okay, so many of these exercises, right, of reading the text, the business rules, as you interview folks and the requirements, you need to be able to say to be able to translate the written text, into constraints that can be enforced in the database, right? So that exercise is the part of designing a database, right? Going from a written language, right, and requirements down to enforcement and implementation of the database itself. So here's a couple of examples on just some random data of sections, courses, professors, year offered, and some of the examples here in red are breaking some of the constraints, right? So for instance, the first two, where you have the professor and the year offered repeating themselves, right, is breaking the first one, right? The later ones, course and year offered, repeating themselves is violating the second constraint, right? So it's data that otherwise would make total sense to you. Yes, it can only be interpreted whether the data is okay or not based on the requirements. Only the requirements will tell you whether the data that you're collecting and the way you're storing it, whether it's appropriate, right? For you, it might be just fine, right? That you have a professor, twice in the same year. It makes total sense. Not until you have read the requirements and says, no, wait a minute, it's breaking a requirement. So it is the requirements that tell you whether the data structure that you chose is correct. Okay, it's not because you think it's completely sensible the way you're storing the data, right? So the requirements drive the data storage, right? The design of the database, and it might be that once you've deployed it and it's running and you've met all the requirements so far, that later on, a couple of years later, new requirements come up and invalidate the data structure that you have been using, for a decade or so, right? It says, well, no, actually, your data structure no longer is valid because this new requirement came up, and now the data set that you have is invalid. So somehow we need to be either find out how else we can enforce these business rules, or do a migration of the data set if it's warranted. Yeah, duplicate records, as I mentioned earlier, the database, if you have records that have the same identical data, the database cannot tell the records apart. And by default, databases won't enforce uniqueness. You have to explicitly say that you want this kind of uniqueness. And primary keys are the main mechanism by which we typically achieve a uniqueness. You could otherwise, instead of using primary keys, you could say this field is unique, right? But it's not a primary key. For instance, you might have that my social security number is my primary key, but I could also enforce the fact that as a person, I have a unique email, right? But perhaps I'm not using that as my primary key, right? But I want to enforce that the emails have to be unique. Yes. So primary keys not only say that it's unique, it also enforces the fact that it's going to participate in a relationship with other records. Other records are going to refer to that primary key. Ideally, primary keys, ideally, we would choose natural fields that represent real phenomena. Okay, maybe an email, a username that everybody's using day to day, to log in or whatnot. Ideally, it would be a natural key. Oftentimes, that cannot be enforced, or it cannot be guaranteed to be unique. So oftentimes we fall back on fields that are not natural, okay, unnatural or artificial keys that, like your student ID. Your student ID is a field that is not natural, right? Somebody just came up with this unique identifier, right? Because they want to guarantee at all costs, right, that they have a unique number to refer to you. It is artificial, right? Ideally, it could have been something natural key, right, that refers to something physical, analogous in real world. Again, like an email, like foreign keys, as I mentioned earlier, they are used for referring to the primary keys and setting up the relationship between records. Here we have a couple of foreign keys in the schema that we're looking at. The major ID in the student is referring to the department in the course is referring to the department, so on and so forth. So we looked at that already. All right, let's talk about schemas.